We want to protect our passwords with a password manager. Do we need one? Any risk with that? Let's check. So what is a password manager? The password managers let you create and store complex passwords without needing to memorize them. Instead of memorizing dozens of different passwords, you can keep all your passwords in the password manager tool. Then you can use the password manager to autofill the account you want to log into. You don't need to hide the passwords under your keyboard or behind the monitor. The tool will remember that. It is endorsed by many government agencies like NIST or National Cybersecurity Center in UK. So how password manager tools work? The password managers rely on encryption to protect the credentials and making them resistant to unauthorized access. Despite occasional media reports pointing out vulnerabilities in the password managers, some providers have not experienced any security breaches so far, thanks to their ongoing development and advanced security measures. Some password manager can even alert to phishing sites, enhancing protection against online fraud. The password managers not only eliminate the need to remember multiple passwords, but it can also automatically generate highly secure and complex passwords. If you want to see how the encryption works, you can check the Bitwarden presentation. It went to very detailed to explain the encryption process. In this presentation, I will review a recently discussed free open source password manager called KeePass Password Safe. I will also explore the fundamental aspects of the password manager's security, investigating or identifying the potential risk associated with the use of it. Ultimately, I will discuss making an informed decision about whether to adopt a password manager or not. You must be thinking by now, why not SSO, single sign on? Single sign-on or federated identity management, those are modern approach, and it makes sense to choose SSO over a password manager solution when applicable. Remember, SSO is designed to authenticate a single credential, which is a password, across various systems within one organization. And FIM, Federated Identity Management System, offer single access, a password, to a number of applications across various enterprises. So when your multiple applications are not part of that single organization or not under the federation, you still need to use many passwords for many applications. In that case, password managers are excellent solution for individual use, allowing access to necessary applications efficiently. Any risk with password managers? In recent months, there has been significant attention on various CVE. You can see these numbers. These are as current as March, April, and May. The issues have gained official recognition from US government. That's why we are seeing a CVE number. So featuring its significance, I wanted to check the CVE number 32784, what has been termed as a master password crack. It's discovered a vulnerability in KeePass Password Safe, which is an open source password manager. Since the topic has sparked considerable interest, I wanted to dig deep to examine the exact risk. A GitHub user named VD Honey, you can check the name, it's the same name you can find in GitHub. The GitHub user revealed that for KeePass version earlier than 2.54, in the KeePass password set version earlier than 2.54, the traces of master password remain detectable in the computer's memory dump, even if some time has passed since it was entered. So, to gain a better understanding of how the attackers might attempt to subvert the KeePass password safe, I installed an older version, 2.52, and verified that it indeed functioned as described by the GitHub users. So I entered a password, short length password with this one, and you can see it started finding out the traces, and it actually broke the password. The first character is missing only. So now I actually wanted to give a longer password to check if it is about the length, and this time the length is pretty long and it has uppercase character and digits, and you can see it's almost broke it, just the first character missing. In the original description of the CV, it is mentioned that the password for this detection, the password needs to be entered through keyboard. So I actually wanted to check that, and this time I did a copy paste and there is no luck. So with copy paste, I could not find the password. So I downloaded the password dumper from the when I entered the password, I took a process dump, and using the script from the GitHub, I ran the script, and the passwords are coming, but it did not come when I entered using the copy paste. So to dig deeper and to gain some insights into the inner working of the software, I decided to examine the KeePass password manager using a reverse engineering tool called Ghidra. You don't need to be a reverse engineer expert in order to use Ghidra. There's an excellent feature in Ghidra called search, and I started searching for master key, and all the functions started appearing. Through some initial investigation, I checked all the master key functions like get master key, set master key. When I started opening them, I found something called .NET CLR managed code, which led me to focus on a particular aspect of .NET programming, which is strings. If you are familiar with .NET programming, you probably know that strings play a crucial role in .NET application. Unlike many other data types in the CLR common language runtime, strings do not have a fixed size. The flexibility makes them ideal for placeholder and dynamic data. The actual data represented by the text is contained within the string object itself. So that explains that why strings are extensively used in .NET program. So since it is a .NET application, I got a .NET debugger, which is DNSpy. You can find it online. And I started opening the functions, particularly the user interface, and I started looking at them. I opened the source code, and within the text box, the secure text box X, I started examining how the text box is used for the master password entry. So you can see there is actually a placeholder. So I have it clear. I have it here. The dot actually. So examining the secure text box X, the source code, I observed how these residual strings were generated. The dot is the actual placeholder for the to be entered character in the right. So for the first character, there is no placeholder in the right and there is no residual string in the memory. To check further, oops. So what should we be concerned about? Should we be concerned about this bug? This bug is indeed a vulnerability. However, it can only be exploited if attackers have physical access to the hard drive to obtain a memory dump or process dump. So if you have a BitLocker or similar disk encryption, attackers won't be able to access the swap file or the hibernation file, not the process dump. Now, if the computer is already infected with a malware, of course there is risk, as attacker can employ other methods too, such as keylogger, etc. So therefore, no need to be overly concerned about this bug. However, the CVE serves as a lesson. It emphasizes the importance of secure coding, or after the coding, check the secure functions, etc. So the KeePass developer Dominic Reichel responded the GitHub users' concern promptly and resolved the issue in the next version. He also recommended that existing KeePass users change their master password, restart their computer, delete the hibernation file, page file, swap file, and overwrite deleted data on the hard disk drive to prevent data retrieval. So, what's now? I double checked if the fix is working. So I installed a later version, current version 2.55, and I observed that KeePass now addresses the placeholder issue, creating a function called dummy string. So this create dummy string function generates random fragments with random characters matching the length of the current password in the process memory. This makes it challenging to determine the correct managed string, resulting in a failure to extract the password from the memory dump. Here is a side-by-side comparison. So this is how it was stored before, and now the create dummy string is collecting the password. So coming back to our original question, should we adopt a password manager? The question is, check why do you need it? If the ease of use is the primary reason for local password manager adoption, then that can relate to the password feature, SEB password feature, autofill, user interface design, ease of installation, etc. You also need to check the security features. Is the encryption method reliable? Secure backup possible? Are you updating as guided by the vendor or the developer? If there is a potential vulnerability or published CVE, always try to examine the vulnerability if you have tools and capabilities. Also check if there is a remedy. After the remediation, check if the risk is gone completely. Remember, your cybersecurity knowledge can play an important role in protecting the key of your kingdom. If you have any question, you can post in discussion board. I'll be happy to reply. These are the tools I used. All of them are available online and free. Thank you.